Hello everyone, my name is Tami. Today I am going to talk about several mid-latitude climates. First of all, I will explain the Koppen climate classification, and then I will introduce you to the climate type and classification of it. Then we will talk about the geographical distribution of climate type D, and I will give examples from Canada to explain the temperature precipitation analysis of DF climate. Also, I will give examples from Toronto to showing temperature precipitation analysis of DFA climate. So, I will give three building examples, which is vernacular, historical, and modern, and I will show the 3D model of each of them. And then I will show the sun path and shadow analysis of vernacular one, and additionally, I will show energy analysis of the vernacular one again. So, the Koppen climate classification divides climates into 5 main climate groups, with each group being divided based on patterns of seasonal precipitation and temperature. The 5 main groups are A. Tropical, B. Dry, C. Temperate, D. Continental, and E. Polar. Each group and subgroup is represented by a letter. All climates are assigned a main group, the first letter. Introduction of D climate type, continental. Continental climates are usually situated in the interior of continents. They have at least one month with an average temperature below 0 centigrade degree. Likewise, at least 1 month average above 10 centigrade degree. Here, winters are very cold along with strong winds as well as snowstorms that come from the continental polar regions or the Arctic air masses. It also experiences drastic shifts during seasonal changes. Typically, continental climate range from 40 degree to 75 degree latitudes in the northern and southern hemisphere. However, this type of climate type is rare in the southern hemisphere. Here is the classification of D-type climates. It has lots of subtitles. And according to classification, subtitle A represents hot summer. So DFA, DSA, and DWA represent hot summer humid continental climates. This climate type is the coldest month averaging below 0 centigrade degree, at least 1 month's average temperature above 22 centigrade degree, and at least 4 months averaging above 10 centigrade degree. No significant precipitation difference between seasons. Subtitle B represents warm summer, so DSB, DWB, and DFB represents a humid continental climate. This climate type is a climatic region typified by 4 distinct season and large seasonal temperature differences, with warm to hot and often humid. Summers are freezing, sometimes severely cold in the northern areas, winters. Precipitation is usually distributed throughout the year but can have drier or dry season. Subtitle C and D represent cool summer and very cold winter. So DSC, DWC, DFC, and DSD, DWD, and DFD represent subarctic climates. It's also called subpolar climates or boreal climates. It's a climate with long, cold winters, often very cold, and short, warm to cool summers. It's found on large land masses, often away from the moderating effects of an ocean, generally at latitudes from 50 degree to 60 degree north. Poleward of the humid continental climates. Subarctic or boreal climates are the source regions for the cold air that affects temperature latitudes to the south in winter. Now we will continue with the Canada example, DF climates. Temperature precipitation analysis of DF climates. In Canada, the climate is Arctic in the northernmost areas, subarctic in the central areas, and continental in the south, where the main cities are located. The only exception is, in the southwest, the coast of British Columbia, Sea Vancouver, facing the Pacific, where the climate is oceanic, cool, rainy for the most of the year. On the east coast, Nova Scotia, Newfoundland, facing the Atlantic Ocean. The influence of the sea is reduced because a cold current, the Labrador Current, flows there. The sunniest area is that of the Great Prairies, east of the Rocky Mountains, in cities such as Calgary, Winnipeg, etc. The sun shines more than 2,300 hours per year. However, southern British Columbia, Sea Vancouver, is also sunny in summer and Arctic regions see alert in late spring. The graphics shows the trends in annual temperatures across Canada. As we can see, the temperature increased year by year. These graphics represent the change in seasonal precipitation of Canada. Again, we can observe the increasing precipitation year by year again. Here is the trends in seasonal temperature across Canada, and season by season it changes. It's same for change in seasonal precipitation. Season by season it changes. We will continue with the DFA climate analysis, and DFA climate is humid continental climate, and I will give examples from Toronto. Here is the climate chart of Toronto, a guideline that lead design and creativity in Toronto, Canada's largest city and the capital of Ontario. The climate is continental, with very cold winters and warm summers. Although the city is located in the south of the country, winter is cold because the North American continent cools down a lot and outbreaks of polar air masses are frequent. However, being that is exposed to different types of air masses, jumps in temperature are frequent. When we look at the climate data for Toronto, we can see the maximum, daily maximum, daily mean, and daily minimum centigrade degrees. Also the average precipitation, average rainfall, and average snowfall. Seasonal climate characteristics of Toronto. In winter, snowfalls are frequent, so much so that it snows for several days per month. Occasionally, real snowstorms may occur. Sometimes, the phenomenon called ice storm or glazed ice may occur. That is rain that falls on frozen ground, freezing everything, roads, trees, light poles, cars, etc. In spring, from mid-March to May, is an unstable season, characterized by changes in temperature, initially cold in March, with snowfalls and frost still quite frequent. It advances gradually, with the first warm days, but also the return of cold weather, and it is still on average cold in April, when it can still snow in the first half of the month, while it becomes mild in May, when also afternoon thunderstorms starts to erupt during sunny days. In summer, from June to August, is warm, with highs usually about 26 to 27 centigrade degree. On hot days, when the temperature can reach or even exceed 30 centigrade degree, it can also be muggy because of the humidity brought by Lake Ontario. However, in summer there are also cold and cloudy days, while in days of fine weather, which are cooled by the breeze from the lake, thunderstorms can erupt in the afternoon. Sometimes even hot waves may occur, with highs around 36 to 37 centigrade degree, generally of short duration. In autumn, from September to mid-November, is initially pleasant, since there are many sunny days, with temperatures exceeding 25 centigrade degree. These periods, called Indian summers, occur in September, but sometimes also in October. As weeks pass, however, the temperature decreases rapidly, low pressure areas become more frequent, and the first cold days occur. Now, I will give three examples. First one is vernacular building, Red River Frame House. The Red River Frame House is a type of vernacular architecture developed by early settlers in the Red River Valley, particularly by the Meadows. These houses are characterized by their use of local materials, such as logs and chinking, and their adaptability to the local climate. The design often includes features like thick walls for insulation, steeply pitched roofs to shed snow, and small windows to minimize heat loss. You can see the 3D model of Red River Frame House from different angles. Second example is historical building, Maison Saint-Gabriel. Maison Saint-Gabriel is a historical frame house in Montreal, originally built in 1668. This simple yet sturdy stone house was used by the sister of the Congregation of Notre Dame to accommodate Les Filles, the king's daughters, young women sent to New France to help populate the colony. The design features thick stone walls and a step roof, reflecting practical solutions for the local climates. You can see the 3D model of Maison Saint-Gabriel houses from different angles. The last example will be modern building, the Roy Building. The Roy Building is a modern residential high-rise in Halifax, Nova Scotia. It features a clean, minimalist design with an emphasis on simplicity and functionality. The building incorporates large windows for natural light and energy-efficient materials and systems. The straightforward, modern aesthetic reflects current trends in residential architecture, focusing on sustainable and practical design. All these examples demonstrate how residential buildings in Canada have evolved from simple, functional designs using local materials to more modern, efficient structures, all adapted to continental climate in different cities. can see the 3D model of the Roy building from different angles. Now, we will talk about the sun path and shadow analysis of Red River Frame House. This table shows us seasonal and hourly sun path and shadow analysis of Red River Frame House. On the 21st of March, sunshine starts at 6:30 a.m. and sunset starts at 5:30 p.m. On the 21st of June, sunshine starts at 4:30 a.m. and sunset starts at 7:30 p.m. On the 21st of September, sunshine starts at 6:30 a.m. and sunset starts at 5:30 p.m. You can see the 21st of March and 21st of September is the same because these are the equinox dates. Finally, on the 21st of December, sunshine starts at 8:30 a.m. and sunset starts at 3:30 p.m. Now, we will see the energy analysis of Red River Frame House seasonally. First one, energy analysis of March. Second one, energy analysis of June. Third one, energy analysis of September. Fourth one, energy analysis of December. Additionally, I will show the sun path and shadow videos of this building.